Okay. So now, see, first let me introduce myself. My name is Professor Sneha Limaye. I have a teaching experience of more than 10 years now. Okay. And I have been teaching maths since a long time now. Now, I started my career from a very lower standards, like from fourth standard, for fourth standard students, I started teaching Vedic maths. And in this way, I have expanded myself. So now, the reason that I'm telling you all this is that if you have any doubts, okay, even if you feel that you know that the doubt is very simple, I'm not able to understand or whatever it is, feel free to talk to me. Okay, so I can change my teaching pattern in order so that you understand it better. Huh? And any sort of basic questions if you have, do ask me. Okay, so let us start with today's topic, that is complex numbers. Now, first, let us start with a few types of numbers or few number systems which you already know up till 10th standard. Can you tell me what is n? Do you know what is n? N is a set of natural numbers. Hmm? And natural numbers start with 1, 2, 3 and so on up to infinity. Then comes whole numbers. Whole numbers start with 0, 0 up to infinity. Then comes integers. You know what are integers? Tell me. So they are negative numbers, 0 and positive numbers. Okay. Then comes rational numbers. Do you know what are rational numbers? Rational numbers are always in the form of P upon Q, and Q should not be equal to 0. Can you tell me why? If Q is 0, can such a number exist in maths? No. Why? Because the denominator can never be 0. Okay. So R is a set of rational numbers in the form of P upon Q, where Q should not be equal to 0 and P and Q are integers. Why integers? Because they can be negative numbers, 0 and positive numbers as well. Now, after this comes a set of rational, so these were irrational numbers. Can you tell me what are irrational numbers? These were the rational numbers which I told you. Tell me which are the irrational numbers. Very good. Root 2, root 5 are irrational numbers. Okay. Now there is a concept called as real numbers. Do you know what are real numbers? What are real numbers? Real numbers can comprise of natural numbers, whole numbers, integers, rational numbers, and also irrational numbers. Am I right? Okay. So now these are called as real numbers. Now in today's topic, the topic is complex numbers, chapter 3 of part 1. Complex number, when we talk about a complex number, as the name suggests, a complex number always consists of real number plus imaginary number. Okay, so let me give you an example of a complex number. 2 plus root 3i. So this I is for imaginary number. This part is always the real number and this part is the imaginary number. So a complex number, if you see in the textbook, the definition of complex number is given as, let me read it for you. Okay, so now if you see, they have given you the equation x square plus 1 is equal to 0. Can you see that? So now when we say x square plus 1 is equal to 0, can you tell me what are the factors? See, suppose if this is x square plus 1 is equal to 0, can I write x square as minus 1? Now, in order to find out the value of x, what will be the value of x? Square root of minus 1. Square root of minus 1 is always equal to I, which is an imaginary number. Okay. So if I want to find out I square, what will be I square? Think and answer. What will be I square? If I say the value of I is equal to square root of minus 1, what will be the value of I square? Yes. Okay. Now if I want to find out I cube, so how can I write I cube? I into I into I. Now what is I square? What is the value of I square? So I am going to write I cube as minus I. Understood up till here? All of you? अथर्व समजलाय? Complex numbers आपण सुरू केलाय. Complex numbers is made up of real numbers plus imaginary numbers. म्हणजे जे मी इथे एक्झाम्पल दाखवलंय ऑफ कॉम्प्लेक्स नंबर्स, दिस इज अन एक्झाम्पल ऑफ कॉम्प्लेक्स नंबर. This is the first is the real part and second is nothing but the imaginary part. Okay. So आता आपण expression consider केलं x square plus 1 is equal to 0. त्याच्यावरनं we found out the value of x to be root of minus 1, which is nothing but I. So I square, if you want to find out, it is going to be minus 1. I cube is going to be I square into I. So I cube is equal to minus I. Up till here everybody is understood? Any doubts? Online students, any doubts? Okay. So please write down a few things. First, give the heading as complex numbers. Give the heading as complex numbers. And write down the definition that is given in the textbook. On page number 33, 3.2, they have given you definition of a complex number. The number of the form a plus ib. The number of the form a plus ib is called a complex number where a and b belong to real numbers and I is equal to square root of minus 1, which is called as a complex number, and complex number is always denoted by z. Z is equal to a plus ib. A complex number is always denoted by z. Okay, this is very, very important. All of you, please remember this. So if you can see, the real part of z is a and the imaginary part of z is b. Okay, so b is called as the imaginary part. Finish writing? Let me know after you finish writing. Ata, tell me, what do you think? Now you know what is a complex number. Where do you think will the complex numbers be used? Or why are you as commerce students learning this concept? Can you tell me? What will be the reason? Any idea, any guess? Let me know. See, now the main reason is complex numbers are what? Complex, as the name suggests. So when the calculations are very big or very large amount of calculations are there, that time complex numbers are always used. Okay, so when you are going to do a lot of calculation, when lot of huge numbers are present, that time complex numbers will help you. Okay, so as the commerce students are taught this particular topic. Now I am going to write down a few numbers. Okay, and I am going to ask each one of you, what is the real part, what is the imaginary part. And you're going to tell me your name also, because I don't know everybody's name except Atharva's. Okay, so what's your name? Romil. Okay, so now Romil, tell me, 2 plus square root of minus 5. Can we say this is a complex number? Why? See, now this part, this entire part comes under real numbers only. Okay, is there any I? I is not there means what? I can write it down like this. So now can you say it is a complex number? Okay, so Romel has answered me. This is a complex number. Next, what's your name? Gargi. Gargi, tell me, is 2 plus 4i a complex number? So tell me which is the real part? So basically the value of a is going to be 2. Value of b is going to be 4. Correct? Yes, what's your name? Abhi? Okay, Abhinandan. Tell me, is this a real part? Then again the imaginary part can be written like this. Atharva, if I write just 4i, will this be a complex number? How? 4 is imaginary. And is there any real part? No. So real part I am going to take it as 0 plus 4i. Now this becomes a imaginary number. So understood? Even if 4i is written, still you will say it's an imaginary number. So write down these examples. A few examples which are given in the textbook. That entire table, please write it down. The table which you can see in your textbook. Online students, if anybody has any doubt, do let me know. Just a minute. Okay. I can see Swati is online. Who else is online? Okay, online students, if you have any doubts, please ask me, let me know. Now, if you go to page number, wait, 34 of your textbook. There are a few points that are written, the 4 points which are important. I am going to read those points which are given in your textbook. A complex number whose real part is 0 is called as an imaginary number. Such a number in the form z is equal to 0 plus 4i, in our case 0 plus 4i. So here the value of b is going to be 4, and the value of a is going to be equal to 0. Okay. Second point, a complex number whose imaginary part is 0, it is called as a real number. So now tell me, is this a real number? Because imaginary part is not present. It is 0 means what? It is not present. So this is going to be a real number. Then z is equal to a plus 0i, which is nothing but a for every real number. Also, a complex number whose both real and imaginary parts are 0 is the 0 complex number. So if I write down everything as 0, 0 plus 0i. So this is called as a 0 complex number. And the last part, the set R of real numbers is a subset of C complex numbers. You know what are sets? You had studied, all of you, in 9th standard. Okay. So when I say real numbers are a set of complex numbers. If I say this is a set C, so these are complex numbers. Inside complex numbers, there will be real numbers. Also, there can be imaginary numbers. Understood? Okay, now next. Let us go to the conjugate of a complex number. Now, up till now, we have studied what is a complex number. Till here, anybody, any doubt? Romil, Abhinandan, Atharva, Gargi. Okay? Alright, so now let us go to the next part, that is conjugate of a complex number. Give the heading, conjugate. conjugate of a complex number. Conjugate of a complex number. Now, all of us know that z is nothing but a complex number. So, if I write down the number as 7i minus 2, is it in the original form? What is the form of z? A plus ib. Is it in the original form? No. Convert it to original form. So, how will you do that? I am going to write down z as 2 minus 2 plus 7i. Okay. Now, what are the values of a and b? A is equal to minus 2, b is equal to plus 7. Okay. So, when I write this down, now this is my complex number. I am going to write down the conjugate of complex number, which is shown like this, z bar. Okay. Now, what is conjugate? The middle sign. What is the sign of the imaginary part? Plus. It is going to change to minus. So, this is going to be my conjugate of my complex number. Understood? Always the real part sign will change in case of conjugate. So, first step, convert it into the normal form a plus ib and then find out the conjugate. So, if you can see, they have given the entire table. Please go through the table which is given in your textbook. 3 plus 4i, the conjugate of that is 3 minus 4i. Textbook आहे अथर्व? तुझ्याकडे textbook आहे? आहे ना? नाही आहे, पुढे येऊन बस, तुझ्याकडे आहे textbook, शेअर कर त्याच्याबरोबर. कारण काय आहे, always remember when you come for my class, you should carry a textbook. That is a must. Okay? मॉड्यूल नाही भेटेल. इथे बसलास तरी चालेल, म्हणजे मग नीट बघता येईल. दोघांना बघणं जास्त सोपं जातं. Okay, so now if 3 plus 4i, if you can see that table, can you see the table? Z is given as 3 plus 4i. What is the conjugate of that? 3 minus 4i. Then next 7i minus 2. The conjugate of that is minus 7i minus 2. Conjugate of 3 is going to be 3 itself. Why? Because 3 is a real part. Real part ची sign change करतो का आपण अथर्व? नाही. So it is going to be 3. Next 5i, because imaginary part we will change the sign. 2 plus root 3, 2 plus root 3 itself, because it's a real part. And 7 plus root of minus 5 can be written as 7 minus root 5i. How? सांग बरं अभिनंदन कसं? आता हे बघा, 7 plus, करेक्ट. हे लिहिताना आपण कसं लिहिणार? This can be written as 7 plus root of minus 1 into 5. बरोबर? So this will become 7 plus root 5. And what is root of minus 1? I. Understood? Now write down the properties of conjugate which they have given in the textbook. Please write them down. Write down all the properties of conjugate given in the textbook on page number, as I told you, 34. Wait, let me check if I am able to open the textbook part here. Wait, I'll just check. Just give me a minute so that if the textbook is available, I think the PDF is there. So let me see if I am able to download it. Oh, good, perfect. So that I can show you the textbook also. Okay. So now these are the properties which I am talking about. Properties of complex number. Z bar, is it visible to you? On the screen? Visible? Huh? So please write down the properties. If z bar is equal to z, z bar of bar, that is equal to z. If z is equal to z bar, then z is a real number. If z is equal to minus z bar, then z is an imaginary number. Easy to understand? All of you? Sorry. Finish writing? Now let us go to the addition. Now equality of two complex numbers, as you can see over there. Online students, are you able to see the textbook correctly? Just give me a minute. Now entire textbook is visible. Okay. So now if we go through equality of two complex numbers, let us check what is the definition. Two complex numbers z1 is equal to a plus ib and z2 is equal to c plus id are said to be equal if their real and imaginary parts are equal. So now tell me, what is the real part of z1? A. Real part of z2? C. Imaginary part of z1? B. Imaginary part of z2? D. Huh? So now if we want to add or subtract a complex number, okay, now suppose there is one complex number z1, 4 plus 6i, z2 is minus 2 minus 8i. If I want to add these two numbers, z1 plus z2, always you will be adding the real parts. So if I add 4 and minus 2, what is the answer? 2. Then I am going to consider the imaginary parts. Now in imaginary number, this is minus 8, this is plus 6. So what is minus 8 plus 6? Correct. Understood how to do addition? In the similar way, let us do subtraction also. Tell me, when I write z1 minus z2, again, real numbers you will have to subtract. Also, plus 6i minus of minus 8i. So this is going to be 4 minus of minus 2, Gargi, plus 6. Okay. And this is plus 6 minus of minus 8. So Romil, plus 6 minus of minus 8 will be plus, because minus of minus 8 is plus 8 plus 6, that is 14i. So addition subtraction is easy. Have you understood, all of you? Okay, addition subtraction is very easy. Now let us go, okay, so let us go through the properties which are given over here. So now these are the properties of addition. So now I think in 9th or 10th standard maybe, there were few properties called as commutative property, associative property. Have you heard of these properties? The meaning of commutative property in addition, okay, even though you change the sequence, the answer remains one and the same. So that is commutative property. The second property that is shown here is called as associative property. Associative means grouping. So here what they have done, they have grouped Z2, Z3. So first they have solved that part, then they have added Z1. Next, it is called as additive inverse. Okay. So this property, third one, is called whenever you add 0 to a number, we get the number itself. Next, Z plus conjugate of Z gives us the answer as 2 into real part. Okay, just write down all these properties, and I'm going to write down the examples also. First write down the properties, then I'll tell you what example to write each one. So write down the first property, Z1 plus Z2 is equal to Z2 plus Z1, and write down the example as, okay, first write down the properties, then I'll tell you the examples. That is more easier. So write down all the properties of addition. Online students, anybody, any doubt? Are you understanding what I'm trying to tell you? Please write in the chat box if possible, so that I understand whether you have understood this or no. Okay? Please somebody write down in the chat box. Write down the properties of addition. Then I'm going to give example for each and every property. So is my speed okay for you guys? Huh? If you're not able to understand, if I'm going too fast, too slow, do let me know. Have you finished writing down? All of you? Now, okay, give the examples. Write down the examples. Write down, take this example only. Write down Z1 as 4 plus 6i, Z2 as minus 2 minus 8i. So, check whether Z1 plus Z2 is equal to Z2 plus Z1. That is the first That is the first property that is given. Check whether this property holds true. So we have done Z1 plus Z2, answer is 2 minus 2i. Let us do Z2 plus Z1. Z2 plus Z1. So what is our Z2? Minus 2 minus 8i plus 4 plus 6i. So take the real parts together, then the imaginary parts together, and then solve. So this is our LHS, this is our RHS. Both are equal, so the first property is verified. Understood? And after this property, or the first property, just write down commutative in bracket, so that you understand it is commutative. Even though order is changed, the answer does not change. So write down commutative property. Okay. Now next property was Z1 plus in bracket Z2 plus Z3. So we will add one Z3 also. Take this same Z1 as this, Z2 as this, and take Z3 as Z3 as minus 4 minus 2i. After property number 2, write down in bracket associative. It's an associative property, that means grouping in bracket you can write down. Associative, or you can call it as grouping. Associative property, which is also called as grouping. Okay, so now substitute the values in this property and check whether you are getting LHS equal to RHS. So first what you will do, you will add Z2 plus Z3. Okay, Z2 plus Z3. So now what is Z2 plus Z3? This is our Z3. This is our Z2. This is our Z3. So add these two. So Z2 plus Z3. You will solve because the property is like this. So first add Z2, that is minus 2 minus 8i, plus Z3, which was minus 4 minus 2i. Okay, so inside bracket it will be minus 6 minus 10i. And now find out what is Z1. Z1 was 4 plus 6i. So first we have solved the bracket part. Now we are going to add the real part and the imaginary part. So as you can see, answer is minus 2 minus 4i. Now check what is Z1 plus Z2. First solve this and add Z3 in it. Okay, wait. I hope it is visible now. Now solve what is Z1 plus Z2. Our answer of Z1 plus Z2 was 2 minus I. 2 minus I, and then add Z3 to it, which is 4 minus 4 minus 2i. So when you solve this, it is going to be 2 minus 4, that is minus 2. And this has to be equal actually. Answer is minus 3i. LHS is not coming equal to RHS. Why? Minus 4 minus 2i. This is 2 minus 2i. So 2 minus 2i and minus 4. Got my mistake. Here I have to write 2i. I forgot to write 2 over here. Answer is minus 2 minus 4i. So that means LHS is equal to RHS. So this property is also proved. Understood? यहाँ पे I will write 2i better, in a better way. So this is going to be my 4i. Understood? So this is the second property called as grouping. Next, Next now see the next property, which is when you add 0 to any real number, sorry, 0 to any complex number, the number is complex number itself. No need to prove this. Now consider z plus zi. So now what I'm going to do is I'm going to give you one z. For the fourth property we are going to prove now. So now if my z is 5 minus 6i, can you tell me what is the conjugate of this? What is the conjugate of this complex number? If this is the complex number 5 minus 6i, what is the conjugate of this number? Gargi? 5 plus 6i, that's correct. So now when you are going to add z plus z bar or a complex number with its conjugate, so what answer I am going to get? So this and this is going to get cut. Answer is going to be 10, which is nothing but 2 times of the real part. Correct? Because the real part is 5. समझते का अथर्व? Romil, I like the name Abhinandan a lot. It's a good name. I like it. Okay. And the last is z1 plus z2 bar is equal to z1 bar plus z2 bar. So now so z1 is already taken. Let's say this is our z1. So I'm going to give you one z2 also, which is 4 minus 3i. Okay. So now we have two parts. This is our z1. This is our z2. In order to prove the last property, which is nothing but z1 plus z2 bar. Okay. First let us find out what is z1 plus z2. Write along with me. Answer is going to be 9 minus 9i. So this is our z. Okay, so now z bar we have to find out. So it is going to be 9 plus 9i. Property was z1 plus z2 bar. Now this is z1 plus z2 bar. Now it is going to be z1 bar plus z2 bar. Okay, so let us check what this is. Now tell me what is z1? z1 is 5 minus 6i. So what is the conjugate of z1? Abhinandan? Of z1. 5 plus 6i. Of z2? The answer comes out to be 9 plus 9i. Correct? So this is our LHS. This was our RHS. Both are equal. So last property is verified. Understood? These properties are very important. I am taking so much time in explaining them because I want you to learn these properties. These properties are very, very important. Now, let us just write down few properties of, give the heading as subtraction. Acha, there are no properties. Okay, no properties for subtraction. So what you're going to do is give the heading as subtraction of complex numbers. Give the heading as subtraction of complex numbers and write down this particular example over here. Example number 2 given in the textbook. If you have any doubt in it, you can ask. I'm going to give you 2 minutes to write this example. This is an example of subtraction of complex numbers. Example number 2 that you can see over here. example number 2, as you can see, Z1 is given as 7 plus I, Z2 is given as 4I, Z3 is given as minus 3 plus 2I, then 2Z1 minus 5Z2 plus 2Z3 is given as. So now you know, right, that this is called a scalar multiplication. Have you heard of the concept called a scalar multiplication? So 5 into bracket Z2, that is 4I. So 5 into 4I is 20I. Here 2 into bracket minus 3 plus 2I. So you have to multiply each and every term inside the bracket. So 2 into minus 3 is minus 6. 2 into 2 is 4I. And then you will add the real parts and imaginary parts. So I hope everybody has understood this part. Online students, any doubt? No response from online students. Why? I need some response. Write down in the chat box so that I understand you've understood. Is it done? Everybody is understood? Example number 2. Any doubt? Gargi, any doubt? Now let us solve the multiplication part. Atharva लिहून झालं? Okay, now multiplication. Okay, before that, can you see the powers of I which is written over here? I want you to write them down. I raised to the power 4n, that is I raised to the even number, is equal to 1. I raised to 4n, that means I raised to an even number is equal to 1. I raised to 4n plus 1 means when the value of the indice is an odd number. I raised to an odd number is always I. I raised to an odd number is nothing but I. And then write this down. I is equal to square root of minus 1. I square is equal to minus I cube is equal to minus I, and I raised to 4 is equal to 1. Write these 4 points. So understood this part, everyone? Now let us do the multiplication part. Z1 into Z2. It is very easy. Last 5 minutes we will do one example of multiplication. Give the heading as multiplication of complex numbers. Multiplication of complex numbers. Suppose Z1 is 3 plus 2i and Z2 is taken as minus 4 plus 4i. And you have to multiply Z1 and Z2. So Z1 multiplied by Z2 is going to be 3 plus 2i into minus 4 plus 4i. So now what do you need to do is take first 3, multiply this entire bracket by 3. Then take the imaginary part of Z1, multiply Z2, each and every term inside the bracket by 2i. So now tell me, what is 3 into minus 4? Minus 12. 3 into 4 plus 12i. What is 2i into minus 4? 2i into minus 4 will be minus 8i. Okay. And 2i into plus 4i plus 8i square. Correct? I into I is I square. What is the value of I square? So now I'm going to substitute the value. So minus 12 plus 12i minus 8i minus 8. Take real numbers together. So that comes out to be minus 20. Imaginary numbers together, that comes to be 12i minus 8i, that is 4i. So this is our multiplication. Everybody has understood how to do multiplication? अथर्व, जसं आपण नॉर्मल अल्जेब्राची मल्टिप्लिकेशन करतो, 2 प्लस what we can say 2x plus 4 into 3z minus 4. Same way, binomial multiplication, same way we are going to do for this part, complex numbers multiplication, z1 into z2. Understood all of you? कोई शक? Now we have made a group, right? 11th standard group. So what I'm going to do, all these parts I'm going to explain you today. Okay. We have done with addition, subtraction and multiplication. Division also we'll try to do today. First sum of division. And then what I'm going to do is I'm going to give you a few sums from the exercise. See, each and everything we can't do here. That is not possible. We'll not be able to finish the portion. So the difficult sums will be taken here. And the similar ones or the easy ones will be given as homework. होमवर्क रेग्युलरली करायचा आहे, कंपल्सरी. एवढंच तुम्ही केलत ना तरी तुम्हाला मॅथ्समध्ये यू विल गेट व्हेरी गुड मार्क्स. पण होमवर्क इज अ मस्ट. नाउ लेट अस रीड अबाउट द डिविजन पार्ट. They have given us z1 as a plus ib, z2 as c plus id. These are the complex numbers, and of course z2 is not equal to 0 because the denominator can never be equal to 0. Now how to do a division? See, now they have given a solved example over here. Let us take the example. Yes, also one thing I forgot to tell you, all the solved examples from the textbook are important. So you have to also write down the solved examples. Okay. So now z1 is given to you as 3 plus 2i, z1, and z2 is given to you as 1 plus i. So z1 upon z2 means what? 3 plus 2i upon 1 plus i. Up till here everybody is understood? z2 was what? 1 plus I. Now, in the denominator part, what is the complex number? 1 plus I. Can you tell me what is the conjugate of this? What is the conjugate of 1 plus I? Romil? What is the conjugate of 1 plus I? Tell me. So, what we are going to do is multiply and divide by 1 minus I. So, you understood? The denominator part, you have to take the conjugate of the denominator part and multiply both numerator and denominator by the same complex number. Now, in the numerator, you got this as 3 plus 2i into 1 minus I. So, in the denominator, what is the answer? What is 1 square minus I square? Can I write it down as 1 square minus I square? This is a plus b into a minus b is equal to a square minus b square. That property is used. So 1 square is 1. So I will do the numerator ka multiplication. Upon the denominator, 1 square is 1 itself. And what is I square? I square is, so minus of minus 1 becomes plus 1. So my denominator part is going to become 2. Understood up till here? Now we will do the numerator part ka multiplication. So this is going to be 3 plus 3i plus 2i minus 2i square. Up till here everybody understood? What is I square? I square is minus 1. So this is going to become plus 2. So 3 plus 2 is 5 plus 5i upon 2. So this I am going to write it down as 5 by 2 plus 5 by 2i. Please write down this example of division. Write down this example of division. I hope everybody has understood multiplication and division. If anyone has any doubts, please ask right now. Any doubt, anyone? Yes, I can see somebody has written in the chat box. Let me see what it is. Okay, no doubt. Okay, good. Thank you for answering in the chat box so that I also understand you have understood. Okay. So I think we'll stop here for today. Okay. So we have done addition part, subtraction part, multiplication and division. So everybody has understood this. I hope so. For homework, you're going to write down the solved examples given in the textbook. And tomorrow we'll start solving exercise 1. Understood up till today, whatever I have taught you? So bye bye everyone. Let us stop for today.